Hi, welcome back. I'm Jan Dolzer at Sutter Instrument. Today we will talk about the velocity and how we can use this program parameter on the P2000 puller to shape our pipettes so they meet our needs. We will use a sample program that produces a patch pipette as the starting point. So if you have not watched our video pulling a patch pipette, I suggest you stop right here, go to our YouTube channel and watch that other video first. That will make this video much easier to understand. In this tutorial, we will make changes to a sample program, but we do not want to lose the original program. So we have made a copy of program number 1 in program 71 and removed the write protection. Using program 71, with all parameters still in the original configuration, we are now looking at the glass capillary in parallel view. While we are watching this pull, let's quickly talk about what the velocity is to begin with. All Sutter horizontal pullers monitor the movement of the puller bars. The velocity of the puller bars gives us a very good idea of the viscosity of the glass, which in turn reflects its temperature. So the velocity parameter in essence defines the glass temperature at which the heat is turned off and the hard pull is executed. So a higher velocity value gives the glass more time to draw out, which then leads to a longer taper of the final pipette. In the meantime, the pipette has finished pulling. So let's rewind and take a look at the hourglass the first heating cycle has produced. If what I just told you is true, a higher velocity should give us a longer hourglass than those 6.5 millimeters, correct? To test my hypothesis, we're changing the velocity on line 1 from 55 to 80. Here's the first heating cycle at the same scale in parallel view, more than a whopping 20 millimeters. We'll put that down here for comparison and run a few more pulls with a velocity in between those two extremes. Our goal is to find out whether there's a linear relationship between the velocity and the length of the hourglass. One important point I would like you to take home today is that we can confidently state the relationship higher velocity equals longer taper. However, I would not like you to think for any type of patch pipette just use velocity 55. 55 is the ideal velocity for this particular program, that type of glass. But different conditions require different values. With that, back to our patch pipette project. We have now completed the sequence and it does not look like there's a linear relationship at all. If we plot the length of the hourglass in a graph and also add a few values at velocities below 55, there's a pretty long stretch when nothing much changes, and then at velocity 70-75 all of a sudden the hourglass gets dramatically longer. In addition, too high velocities are frequently associated with inconsistency. In 1 out of 3 pulls we filmed at velocity 75, we observed something that we refer to as a sausage link. There's a waist in the pipette taper and then the diameter gets bigger again. In addition, in this example, the whole thing is at an angle. I wouldn't want to patch with that. So if you observe sausage links in your patch pipettes, there's a pretty good chance that you have a too high velocity in the second to last line of your pull program, and that you can achieve a lot of improvement by dropping this particular value. You will ask, what happens if you push the velocity even further, in our example to 85 or more? One of two things. If you have a hard pull on the same line, such as the 55 we have in our example, the capillary will draw out far enough to separate on line 1 already. That's what we see here. If you have pull 0 in contrast, which is pretty common for 3, 4 or 5 cycle patch pipette programs, you will often end up with a long wisp and the capillary never separates until the end of travel of the puller bars. The last thing we want to look at in this tutorial is how the final pipettes relate to the hourglasses for each of the different velocities. If we superimpose images of the pipettes over 1/2 of the hourglass, we see that that portion of the tip that extends beyond the hourglass changes very little between different velocities. This zone of the tip is largely determined by the last line of a pull program, in our example, line number 2. But that's the topic for its own separate tutorial. Let me summarize what we learned today. A higher velocity produces a longer hourglass and a longer taper. Too high velocity values lead to inconsistency, sausage links, wisps, or premature separation of the tips. A low velocity, in contrast, produces a shorter taper, and prevents the formation of sausage links. And last but not least, different applications require different velocities. Don't just simply use the 55 from our example today across different pipette styles and for different types of glass. The typical range for your average patch, micro or injection pipette is between 10 and 80, but where in that range the optimum lies, that will vary. That's it for today. We are continuing to produce tutorial videos for the P2000 laser-based micropipette puller. Coming up next is a video that deals with the heat and filament settings. Check out our website or our YouTube channel for the growing collection of tutorial videos. If you need any tech support, go to www.sutter.com or give us a call at +1 415 883 0128.